Okay, this is the review for our quadratics unit test. If you look at number 1, that one has 2 terms, so that is a good example of GCF. The biggest number that we can pull out of 12x squared and 42x are 6, and then our variable would just be x. So we would have 2x minus 7 on the inside. 12 divided by 6 is 2, 42 divided by 6 is 7. That's how I got those numbers. Then we take each part and we set it equal to 0. So we'll have 6x equals 0, and we'll have 2x minus 7 equals 0. And then we solve both. Divide by 6. X equals 0 is one of your solutions. Over here, we're going to add 7 to both sides, and then divide by 2. So x equals 7/2 is our other solution for number 1. Number 2, in factoring, that would be split the middle. So you would do 15 times negative 7. That gets you negative 105. And then we need to find the factors of negative 105. You can list a bunch of them to save time. I know that 21 and 5 work. We have to decide which one to make negative. So since we have this positive 16, we need to do 21 minus 5 to get a positive 16. So that's why the 5 would be negative here. So we're going to go ahead and split our middle. If you wrote minus 5x first instead of the 21x, that's fine. Order does not matter on that. You'll still be able to factor. Okay, so we're going to break up and do factor by grouping from here. 3x goes into our first 2 terms. We would have 5x plus 7 remaining. And then we need to get a 5x plus 7 here to have the same parentheses. So that means we need to pull out a negative 1. We're going to bring down our 3x minus 1. That makes this parentheses here, and then our 5x plus 7 for our second. Again, set both parts equal to 0. And solve. We'll add 1, divide by 3. One of your answers is 1/3. Subtract 7. Divide by 5. And negative 7/5 is your other answer for number 2. Okay, we're going to move on to the next page. Numbers 3 and 4, this is solved by graphing. This is done in your calculator. And so I can't show you that here, but I can give you the steps on that. So if you want to grab your calculator, we're going to start in y equals. You can clear out your y1 and you can enter the equation 5x squared plus 8x minus 13. We're going to be working with number 3 first. Put that in y equals. Once you are there and you have that in, press graph. And from here, we're going to choose second trace. That will allow us to find the zeros. So second trace. And you're going to choose number 2, 0. And you're going to have to do your left bound, right bound. Okay, if you're doing the left side, okay, that 0 that's between -3 and -2, you're going to go above the x-axis, hit enter, go below the x-axis, hit enter, and then right on that 0, press enter. Okay, and you should get -2.6. And just so we know, -2.6 is actually -13/5. So in terms of is this factorable, okay, this first one is factorable. We would not know from seeing the decimal, but once we change it to a fraction, we know that it is factorable, okay? Go ahead and you can do your second trace and do your right-hand side, which is, it looks like it's going to be 1, but you can do it to make sure, and in fact it is 1. So we have our 2 zeros. So in looking at negative 13 over 5 and 1, they are both factorable. Okay, those are rational numbers. Okay, same process for number 4. Okay, here's your steps if you need those for the calculator. Okay, you're going to go to y equals. You're going to enter your equation. You're going to press graph. Then you're going to press second, trace, and choose number 2, which says 0. Okay, then you're going to do your left bound, right bound, and guess. Okay, and that will give you the 0. You'll do that twice. You'll do it for both zeros, assuming that you have 2. All right, so if you do that here, you should get negative 3.35 as well as 1.35. These are actually not factorable, okay? It did say to round to the nearest hundredth. That's 2 decimal places, okay? Is it factorable? Is a quadratic factorable? I guess I should put no there. Not, okay? It is not factorable, okay? And that's how you do that process. These steps will be a good help for you, okay? So if you need this video, you can go onto Canvas. It's a YouTube link, so you can watch it as many times as you need to for the review, if you need those steps. Okay, breaking down square roots. So we always want to see if you can find a perfect square. For 24, 4 and 6 work. Radical 4 is 2, and that's as far as we can reduce that one. Whenever we have a negative under our radical, we pull out an I. Radical 242 breaks up into radical 2 and radical 121. Radical 121s are perfect square. It's 11. So we'll have 11I radical 2 for our answer. For number 7, we keep that negative 3 on the outside. We're going to pull out the I. And we have radical 56. 56 can be broken up into 4 and 14. Okay, and then we can break down that radical 4. That's a perfect square. It's 2. Okay, and then finish our simplifying. Negative 3 times 2 is negative 6. We keep our I and keep our radical 14. Number 8 is a fraction, and I don't want these to intimidate you too much. Just break up your square root, okay? Think of the top and the bottom as separate. So if we break up just radical 8, don't focus on the bottom, we're just focusing on radical 8. Radical 8 can be broken up into radical 4 and radical 2. We'll keep the radical 36 on the bottom because that's a perfect square. Radical 4 is 2. Keep our radical 2, can't break that up, and we have 6 on the bottom. Now, we're not quite done. Right here, we need to break that down. We need to simplify that, okay? 2 goes into 2 once, okay, and it goes into 6 3 times. So we reduce 2 6 to 1/3. You don't have to have the 1 in front, okay? You can easily get rid of that and have 2/3 as your answer. Okay, 150 can break up into the square root of 25 times the square root of 6. We'd get 5 radical 6. The square root of 25, if you were to put that in a calculator, you would get 5. And that's all she wrote for that one. Number 10, same thing, okay, as number 8, except for we have a negative. So we're going to go ahead and bring out the I, okay, and break up the top and the bottom. The top, our square root of 4 is 2, so we'll leave that as 2I, and on the bottom, radical 9 is 3. So our final answer is 2I over 3 for number 10. Okay, number 11, we're doing the quadratic formula. It's up in the right-hand corner of your paper. So since b is already negative, we're going to make it positive. Okay, and I know I'm doing 6 squared, but I'm going to go ahead and write it as 36 so I eliminate some errors that I could make with my square. And we have 2a on the bottom. Okay, if we were to get the number inside the square root, it would be negative 12. 12 can break up into 4 and 3, but we need to bring out that I. Okay, our radical 4 became 2 on the top. Now we can reduce these numbers here. Remember, both of these have to be reducible if you simplify. 2 goes into 6 3 times. It goes into itself once, so we'll just have I square root of 3 there. And then on the bottom, we'll have 4. Number 12, we use the same formula. Negative 5, since it's positive there, 5 squared is 25, minus 4 times a is 3. Ooh, I forgot to move this over. Subtract that 8 over, so it should be a negative 8 that you fill in. Okay, and then 2 times 3 on the bottom. Okay, we have our square root, and we will get 121 over the square root if we put all of that in our calculator. Okay, or if you did it in your head. The square root of 121 is 11. Okay, so here's where we can break these up. This is really nice because we have nice numbers. We got rid of our square root. So this right here would break up into 2 different answers. We have negative 5 plus 11 over 6. We have negative 5 minus 11 over 6. I'm going to come down here and do both. Okay, for our first one, we would end up with 6 over 6, which is 1. And if we did minus 11, we get negative 16 over 6, which is reduced to negative 8 thirds. And those are your 2 answers for number 12. So you can see the difference between 11 and 12. 12, we got some final answers because up here, okay, we got rid of a square root where that 11's at. But over here, you can see we kept trying to break it down, but we still ended up with the radical 3. Okay, 13 through 16 is discriminant. And if you remember for discriminant, our equation for that is b squared minus 4ac. We don't have a radical or anything like that. So if we want to find our discriminant here, we'll have b squared, so negative 2 squared is 4, minus 4 times a, which is 4, times c, which is negative 10. If we get that answer, it should be 164. When we get a number that is not a perfect square, that tells us that we have 2 irrational roots. 2 irrational roots. And we know that when it's irrational, it is not factorable. Not factorable. We're going to do the same process for 14. So b squared would be 25. 5 squared is 25. Times 4 times 1. Times c is 7. This will give us a discriminant of negative 3. When we get a discriminant that is negative, that tells us our number of roots is 2. Our nature is imaginary. Okay, is this quadratic factorable? No. Quadratics are not factorable when we have imaginary or irrational roots. For number 15, we're going to do the same process. Find that discriminant. Negative 6 squared is 36 times a times c. If we worked this one out, we would get a discriminant of 0. When we get a discriminant of 0, that tells us we have 1 rational root. When roots are rational, they are absolutely factorable, so that would be yes. For number 16, our discriminant, we would have 1 squared is 1 minus 4 times 6 negative 35. That gives us 841. That's a big number. We haven't really dealt with a lot of huge numbers like that, but if you were to put this in a radical and take the square root of it, you would get the perfect square, and the answer would be, I think it's 29, but it is a perfect square, and that tells us when we have a perfect square number that we have two rational roots, okay, and they are factorable. I'm going to leave that up for just a second. Make sure that you can get some things copied. If you don't, you can always go back and watch the video online. Just go to Canvas. I'm going to post it as an announcement so that you can see that link. Okay, on to the next section. We are completing the square, 17 and 18. So for number 17, we have 1 in front of x squared. That saves us one step. We don't have to divide. Our first step is going to be to subtract negative 134. Okay, and then we do b over 2 squared. B is always that middle number that's associated with x. So we'll do 12 over 2 squared, that's 6 squared, which is 36. 36 is what we add to both sides. And we're going to factor this side. Remember, our shortcut is to take this number. This is the number that goes on the inside. So you can use 36, okay, and you can use 6. Now, we have to decide what to put here between the x and the 6. Since we have negative here, it carries over down to our 6 and our x. And the negative 134 plus 136 is negative 98. From here, we take the square root of both sides. So here, our x square, or our square and our square root will cancel out. And then we will have on our right, I square root of 98. And don't forget that plus or minus. We want to pull out that I because of the negative of the square root. We can add 6 to both sides. The 6 will come before the plus or minus. Okay, and then we want to see, can we break down the square root of 98? And we actually can. Most people think this was kind of weird that we can break that up, but 49 and 2 work. So we're going to keep the 6. The square root of 49 is 7, so we'll have 7i, and we'll keep the radical 2 as is. Okay, number 18 adds one step because of that 5 in front. Let's retry that one. Okay, I'm going to move my 25 over, and it should be positive. Okay, now we're going to divide everything by 5. So 5 divided by 5 is 1x squared. 10 divided by 5, we have a negative 2x. 25 over 5 is 5. Okay, now we're going to take our b over 2 squared. So we'll have 2 over 2 squared. That's 1 squared, which is 1. So we're going to add 1 to both sides. If it helps you, put the lines there so you know to add it to both sides. We're going to factor. Okay, and we have an x minus 1. We carried our negative down again. This second number was the number that came here. And we simplify our right-hand side to 6. Take our square root of both sides. We'll have x minus 1 equals plus or minus the square root of 6. Add 1 to both sides. We have 1 plus or minus 6 for our final answer. Okay, we're going to keep moving here. On to the back. This section, you can choose any method that you want. I tried to vary it for you so that we do each method on the video. It's really up to you what you decide to do. For the first one, whenever you have two terms, you really don't have an option. That's just GCF. Okay, I would just do greatest common factor. There's nothing else you can really do here. So 3 is what we should pull out. Okay, so we get an x squared minus 9 on the inside. This one's a difference of squares, and I know that's kind of a throwback. We haven't done difference of squares for a while, but it's something that we have learned this year. You can break up that x squared minus 9 into x minus 3, x plus 3. This gives us x minus 3 equals 0, and x plus 3 equals 0. Add 3 here, and we get x equals positive 3. Subtract 3 here, and we have x equals negative 3. Number 20. I'm going to do complete the square on this one. You could really do factoring on this one as well. Actually, you know what? No, you couldn't, because that one is irrational. So I wouldn't suggest factoring. You could do quadratic formula. That's what I meant. So if we do complete the square, we need to subtract 3 first. From there, we can do b over 2 squared. So 8 over 2 is 4 squared is 16. So we're going to add 16 to both sides. Over here, we get a positive 13. Okay, and then if we factor, we'll have an x. We bring down our negative. And we take this number for our factoring. Square root both sides. Add your 4. And that's your final answer. Number 21 is another example of GCF. Okay, 7 and 5 don't have a common number. So honestly, all you can do here is plot an x. So we'll have 7x minus 5. But a lot of you get tripped up. Remember, you still have to set both parts equal to 0. So you're going to set x equal to 0, and you're going to set 7x minus 5 equal to 0. This one's done. This one we need to add 5 and divide by 7. So your other answer is 5/7 for number 21. Okay, I'm going to do quadratic formula on number 22. Give myself a little bit more room here. Okay, quadratic formula is up in the top right-hand side of your paper, so if you need that reference, it's right there for you. Okay, so we're doing negative b. That means negative 2 plus or minus. 2 squared is 4. Minus 4 times a, which is 3. C, which is 5. Over 2a, which is 3. Okay, we're going to go ahead and get the number that's under the radical. If you were to put that in your calculator or do it in your head, you would get negative 56. 2 times 3 in the bottom simplifies to 6. Okay, so then let's see if we can break down negative 56. You should be able to obviously pull out that I. It looks to me like square root of 4, and the square root of 14 should work for 56. Just remember to pull out that I. Okay, from here, square root of 4 is 2, so we'll have 2i, radical 14 over 6. Okay, keep in mind, we can still simplify. Right here, those simplify, and this 2 and 6 simplify. So we will have negative 1 plus or minus I radical 14 over 3. The reason I knew that it was 1 here in both spots is because 2 goes into 2 once, 2 goes into 2 once, and 2 goes into 6 3 times. Okay, on to number 23 and 24. 23, I would love to do quadratic formula, honestly, but I see a really easy way to do split the middle, and that's first pull out a GCF. So we're going to do split the middle on this one. So pull out a GCF of 5. Great, and now we can leave that 5 on the outside, and the inside is where we can do split the middle. So we're going to do 12 times 1, which is 12, and we're going to break that down. Okay, we know we can do 6 and 2, and 4 and 3. 1 and 12 wouldn't really help us. Take a look at that 4 and 3. If we make both of those negative, we can get to negative 7 in the middle. So we're going to use negative 4 and negative 3. So x squared minus 4x minus 3x plus 12 equals 0. From here we factor by grouping, pull out an x. We want an x minus 4 left, so we need to pull out a negative 3 on that second set. So here we would have x minus 3 equals 0, and we'd have x minus 4 equals 0. Add your 3. Add your 4, and we're good to go. Now some of you may be saying, what are we doing with that 5? Well, we would bring the 5 down. If we wanted to make these into factors, okay, our final answer in factored form would be x minus 3 times x minus 4 times 5. But we always want to solve and get what x actually equals. So that's how we get the 3 and the 4. Last one, okay, I would subtract the 9x over. Okay, and then this is just GCF from here. Pull out a 3x, so you have x minus 3 left. Set both parts equal to 0. Divide by 3 on this one. 0 divided by any number is 0. Add 3, and we have x minus 3 for our second solution. Again, if you need this video, okay, it's going to be online for you. If you go to campus, I'm going to post an announcement with the YouTube link on there, and your solutions are on the back of your review as well. So please feel free to ask me questions anytime before the test on Friday.